Hi everyone, so this is our third lesson of the second unit. Today we're going to kind of back up to what we ended the first unit on, which was solving quadratic functions. And there's something related to this that we didn't get to discuss yet, and we're going to look in more detail here in this lesson. So let's just jump into it. So let's try this little warm-up question. It says, solve the following using the quadratic formula. And we've got this equation. It says, use your graphing calculator to verify our answer. So first thing I'm going to do is write out the quadratic formula. So x is negative b plus or minus square root of b squared minus 4ac all over 2a. So we're trying to solve for x when y is equal to 0. So we use this in order to do that. That's one of the ways. If we could factor, we probably would, but I don't think we can factor this one. So remember, a is just the coefficient here, b is the coefficient for the single x term, and then c is the one that doesn't have a variable, so that's 5. So I'm going to plug those in. So I've got negative and negative 9, so I'm just going to make that positive 9. Put that in brackets here. So we plug that all in, and I'd like you to try this, and you'll find that something's going to happen here. Something irregular. So if I keep going, I end up at this stage, and hopefully you get to this point, so you can always pause the video. But there's a key idea here that's happening, and you may have noticed it already, but underneath the square root I have a negative number. And so as a result, if I tried to do this any further, I just don't get an answer. And so it implies something. What this means is that there is no solution, which really means also graphically that there's no x-intercepts. There's no solution, there's no roots. So no solution, whatever you want to call it, no roots. And so you don't get an answer to this question. And that can happen with quadratics. And it makes sense if you think about it visually. This is the algebra behind it. You cannot take a negative square root, so we can't have a negative root, at least in order to get a real number answer. But ultimately, we know that that's not going to work. So if you were to graph this, let's just take a look here. If you go take your graphing calculator, go to y equals, and you were to type in the equation that we had, 12x squared minus 9x plus 5. So you go in there, you type that in, and you go to graph. This is what you see. You ultimately have this parabola that is above the x-axis, and so it never crosses the x-axis because it's opening up. And so you have a situation where there are no x-intercepts. I'm just going to sketch it here. Doesn't have to be perfect. So it's something up here. Maybe it was skinnier than that because it had an a value of 12, but we get the idea. There is no x-intercept. So this idea pops up in a lot of different areas when we're talking in math. And ultimately, if I wanted to know if there was a solution or no solution, the only thing I have to really look at is the stuff that's under the square root. And you would have learned this a little bit in grade 10, but this part under the square root has a special name, this b squared minus 4ac, and it's called the discriminant. So down below here, the discriminant, b squared minus 4ac, so let's write that in, is what's used in order to see if you have any solutions to these roots. And it's called the nature of roots, and that's the name of this lesson. It's denoted with a symbol here, which is delta. And so this is the discriminant. You would have seen that probably in science. Remember, if you're talking about the change in something, you might have also seen it when you're talking about slope, the change in x and the change in y, when you're looking at the slope of a line. So there are a few things we can think about when we talk about b squared minus 4ac, and it's these three situations. So we just saw here, if it's negative, so this, if it is less than 0, which really means negative, we know that there are no solutions. And again, roots, whatever you want to call them, zeros even. So it's something where you have either up above the x-axis going up or below the x-axis going down. You have situations where it doesn't cross the x-axis. Also, you can have this where it's above 0 or positive. So any positive answer, if you were to try to get b squared minus 4ac and sub some values in, if that's the case, then you get two possible answers. So you get two, what we say is distinct solutions. Distinct meaning they are different from each other. So here and here would be my two answers for that. So two answers if I get a positive value. And the last one is if it's equal to 0. And you might remember this one, but what this means is that you have one solution. Sometimes it's referred to as a repeated root. Or two equal roots, or x-intercepts. Ultimately, you get an answer that really is just repeated. It's just the same answer. This will only happen if you have this situation. You might remember it. So when your x-intercept is actually the vertex, and it could be opening up or down, but it doesn't actually pass through the x-axis, it just lays on it and touches it at that. So something like this, you would, if you were to plug this into the quadratic formula, let's say you end up at this stage, -8 plus or minus, and you get a 0 underneath the root, like that. And so that's the situation. If you were to solve this further, you would end up with -8 over 2, which is -4. Obviously, that doesn't represent the visual I showed, but you get the idea, hopefully. It's really this part, this whatever's under the square root that determines these things. So let's try a few examples here, and we'll branch out, and we'll see that this thing pops up in different areas where you can use it in order to help solve for certain things, sometimes for unknowns and other things as well. Let's just practice it. It says, these rules are known as the nature of the roots. So if you were to have a question that says, like the following, for the following quadratic equations, state the nature of the roots, you have to try to remember what that means is that it's asking for the number of roots. So the nature of the roots really is representing the number of the roots. So you could try these yourself, or you can just follow along and write it down. Try to do it as much as you can yourself. But so in this one, I've got A is 4, B is 7, and C is 5. So I just take delta. So I'll say delta is equal to b squared minus 4ac. And I just plug things in. So I got 7 squared minus 4 times 4 and times 5. And I see what happens. So in this one, I get 49 minus 80. And this works out, obviously it's going to be a negative number. I actually don't even care how big or small that negative number is. I just care that it is negative. So the actual answer isn't important as long as you get the sign right. So in this case, I get a negative number. So what this means is, therefore, there are no roots or no solutions because delta is 0. Or less than 0, sorry. Negative. So no solutions because we got a negative answer. So we'll try the next one. If you want to, you can write down A, B, and C, but you don't have to. So sub these things in. So I get 64, and then 4 times 16 is also 64. So I get 0. So therefore, there are 2 repeated. if you wanted to say it that way, or 1 if you want to say it this way, a unique solution or distinct. Because delta was equal to 0. Great. So the last one here, you just have to watch out. Sometimes these things are written not in the order that you would normally expect them. In this one, they have the C first, and then the B, and then the A term. So I'm just going to rearrange it like this. And so are these the same numbers as above? I believe they are. And so we already kind of know what's going to happen here, but let's just go through the process again. So I just really want the b squared minus 4ac. Not a very good delta there. So I get negative 9 squared. Make sure you put the negative in brackets. Otherwise you'll get a negative answer. And then 4 times a times c. And I plug it in, I get 81 minus 240, which gives me a negative 159. So again, therefore, this one, there are no solutions. No roots because delta is less than 0. Great. So let's see an example where you may come across this in some strange situation. So it says find the value of k so that the function y equals negative 2x squared plus 8x plus 2k has 2 equal roots. So in this scenario, we're actually trying to figure out, what number would make this thing so that the parabola sits. If it's 2 equal roots, this is another way of saying one root, one solution. So because of that, I know that this is equal to 0. So one root or 2 equal roots means that b squared minus 4ac is going to be 0. So in this scenario, a is negative 2, b is my 8, and c, the c term is going to be both 2 and the k, so 2 times k. So I'm going to keep that. So this guy is my c term. So I know that 0 is equal to b squared minus 4ac. So because it's one root, I can set it up as an equation, and this allows me to solve for an unknown if I don't know what that thing is. So I can plug all this in. And the c then becomes 2 times k. And I have an equation, because it's equal to 0, I have an equation that I can work things out and try to solve for k. So I get this, that's going to be 8 times 2k. So I can do it in a couple steps. I might do it in one because I'm running out of a bit of space. So this is going to become 16k. So negative 4 times negative 2 is 8. 8 times 2 gives me 16, and then there's a k times there. And so I rearrange this. So let's say we bring the negative 16k over. So it becomes negative 16k rather. And then I'm going to divide by negative 16. So k will equal negative 4. So what that means is that if I was to sub in for here, k equals negative 4, I know I would get a parabola. It looks like it's opening down. I have no idea where it's going to be located, but let's just say it's like this. And I know it's going to be that, something like that. So it allows me to figure something out in order to provide that information. So the next one says 2 distinct roots. So that's the same as 2 answers. In this scenario, that means that this is going to be a positive answer. So we set this up, and this is the first time you've seen this, but you set it up not as an equation, but as what's called an inequality. An inequality is just when it's greater than or less than. And so we're going to use that idea. It's still the same process, and nothing really changes, at least in the work that we're going to be doing, but I know that this is greater than 0. So again, slight distinction. We don't have the equals, so we've got a greater than. So let's just plop this stuff in and see what happens. Really, it's the same numbers as what we just had. And c is still 2k. So I already know the answers to these. So this becomes plus 16k. And I just moved the 64 over just like as if it was a equal sign, like this. And I end up with just, I know this is going to become greater than, I divide by 16. It means that any number that is greater than -4, so imagine a number greater than -4, -3, -2, 0, 20, 200, any number greater than that is going to produce something, parabola that is going to have two roots or two solutions. And then the last one, you can kind of just deduce, if it's no real roots, it means it's less than 0. So that's key. And notice my answers here. The first one we did, k was a -4, equal to. The second one, k is greater than -4. Every other scenario, if I was to set this up, I'd end up with k is less than -4. And you can go through the process if you want. B squared minus 4ac is less than 0, and then try to solve it. But ultimately, you get this. You will always have no real roots when it's less than -4. So that's our final response. So kind of some different scenarios that you may face. And there's a couple in the textbook homework questions to try as well. So give the U-Try a shot. I'll just flash the answers up here, but these are also in OneNote. You can check your answers. So give those a try. Help each other out, see how it goes. And then once you get those done, you can try these in the textbook. So I will be checking to make sure everything gets done. And the last one here, hopefully it goes all right. But if you need to look at the solution, obviously go through it. And it's very similar to the one where we had the k. Okay, let me know if you have any questions, and take care. Bye.